Hey guys, it's Mr. Dugal, and today we're going to talk about volume of pyramids and cones. And volumes of pyramids and cones are a little different than the volume of prisms and even cylinders. We've said all along that volume, the concept of volume, is the area of the base times the height. And that is true for any cylinder and any prism. However, when it comes to a pyramid or a cone, it still sort of remains true, but it's a little bit different, and I'm going to show you why. We're going to start with a triangle. We're going to start just with the concept of a triangle and how it relates to area. So when we go back to the very beginning and we talk about area, we know that area is base times height. So if I were to make a rectangle that was a 3 by 4 rectangle, the area of that rectangle would be 12 because it's base times height. When I go to find the triangle, there are two dimensions again, the base times the height, and you might also hear people refer to that as the length times the width. So there are 2 dimensions here. So we go to slice this triangle to find the area of each triangle. The orange triangle equals the white triangle, so they are each 6. Because there are 2 dimensions, I do the base times the height divided by 2 for a triangle. When it comes to volume now, let's dial back into volume for these two, cones and pyramids. The part that is triangular in nature now is the height. The height of the pyramid and the height of the cone are triangular in nature. The bases for each, the base, this is a right rectangular pyramid, and its base is the same as what a prism would be. If we had a right rectangular pyramid, the base might be the same, but the height is different. The height is, it's a triangle in nature. That is, if we were to look at it from the side, we would see a triangle. And that's the same with our cone here. Our cone might have the same base as a cylinder, but instead of having that kind of rounded rectangular that a cylinder has, it has a triangle as its height. So the question is, if volume is always the area of the base times the height for prisms and cylinders, how could we make up for that when it comes to pyramids and cones? Well, in the same way that area of a triangle was altered because we divided by 2 because it was 2-dimensional, when it comes to the height of pyramids and cones, we end up dividing the height by 3 because these are 3-dimensional items. They have a length, width, and height. So 1, 2, 3 compared to, a flat triangle is 2-dimensional. So we divide by 2 when it's area of a triangle. We divide by 3 when it's a 3-dimensional triangular shape. So when we look at how to do volume for prisms and cylinders compared to pyramids and cones, with prisms and cylinders we know that it's always the area of the base times the height, like we have here. Whereas in comparison, for volume of pyramids and cones, it's area of the base times the height divided by 3. And again, where that comes from is that it's a 3D shape. So since we're triangular in nature, we're going to divide by 3. Whereas with a 2D shape, when it was triangular in nature, we divided by 2. So the number of dimensions determine how many we need to divide by. And just really quickly to help you kind of visualize this is going to be very imperfect, but if you can visualize the cone, for example, we could have a second and even a third triangle put in. If that helps you to visualize it. So the reason we divide the height by 3, and again this is an imperfect drawing, is because it's 1/3 of the height. We don't want to include either red area So that's again why we divide by 3, another way to look at it. So since it's 3 dimensions, we still do our area of the base times the height, but now we divide by 3. So let's put some numbers to this and actually do a couple of these problems. All right, so we're actually going to start with our cone first. And in this case, we need to find the area of the base, always. So area of a circle is pi r squared. And we're going to leave our answer in pi form this time. The radius in this case is 5, so it's going to be pi 5 squared. 5 squared is 25, so the area of the circle is 25 pi. That's my area. Now I need to multiply by the height divided by 3. Again, because it's a 3-dimensional shape, we divide by 3. With triangles in a 2-dimensional shape, we divide by 2. We can simplify 12 divided by 3 nice and easily. That becomes a 4. We're left with volume equaling 25 pi times 4, or 100 pi meters cubed, because it is volume. Very similar with a right rectangular pyramid. This time the area of the base is a rectangle, and the area is base times height, so 8 times 7. The area is 56. In this case, I have 2 different heights. You might see this at times with pyramids. They'll try to trick you. I only ever care about my height standing straight up. I do not care about the diagonal. Some people will call that the slant height. I only care about that when I'm finding surface area. When it comes to volume, it's not a height I care about. So now I'm going to take my area of 56 and multiply by the height of 15, again divided by 3. 15 divided by 3 is 5. The volume is 56 times 5, which is 330 meters cubed. Again, this shouldn't be anything too crazy. It's very similar to finding volumes for prisms and cylinders and any volume problem you've done up until this point. The major difference that I need to remember is that I take the area of the base times the height and I multiply by height divided by 3. 3 because it is a 3-dimensional triangular height. That's about it. Hopefully this serves as a solid foundation for finding volume of pyramids and cones. Thanks so much for watching.